Hello, everyone. Welcome to our presentation on our artificial intelligence project, user identification
Yeah.
using touch gestures. We are group 25. Uh,
Okay.
we are 4 members. So the first member and group leader is me, Shahadat Hussain Parvez. I did basically the literature review, model training, and optimization part.
Hello everyone, I'm Mohammad Umar Kamar and my role in this project was YouTube video production testing and development. I work on preparing the final presentation video and testing the system.
Hello everyone, I'm Ashafur Rahman. I work on dataset preparation and testing and deployment. I helped prepare the dataset and tested the system performance.
Hello everyone. I'm Yogi Nagendra Babu Pokuri. I worked on dataset preparation and model training and optimization. I helped to train the model and improve the accuracy.
In literature review, to understand existing works, we reviewed several studies. First was the touch study, which used swipe gestures and machine learning models like SVM and KNN for user identification. Next, we studied the touch stroke dynamics paper where they analyzed gesture speed, pressure, and acceleration for authentication. We also studied the HMOG paper, which stands for hand movement orientation, which combined touch, accelerometer, and gyroscope data for continuous authentication. Finally, we also looked into the chemical data set, which used synthetic biometric data such as face and eye and ECG for evaluation. This important is this also used swipe gestures. These studies help guide our data set selection and model implementation.
Reviewing the literature, we selected the Archalytic dataset for our project. This dataset includes the data from 41 participants with around 7,800 scroll strokes and 30 features for each strokes. The dataset contains different features categories. First one, spatial feature includes swipe start and position, direction and length. The temporal feature includes swipe duration and velocity. Pressure features measure finger pressure and fingertip area. Kinematic features include swipe movement. Finally, device features include phone model, screen size, and orientation. This dataset help us compare the performance.
After that, next we compare two datasets, HMOG and chemical dataset. HMOG stands for hand movement orientation and CREPS dataset. This dataset includes 100 participants and use touch data, accelerometer, and gyroscope signals. Because it uses many signals, it requires more features extraction. The chemical dataset includes 56 subjects and uses phases, eyes, and ECG data. It also includes swipe features similar to the touch analytics datasets. This dataset requires less feature extraction. This comparison helps us understand the difference between the datasets and select the suitable approach for our project.
Well, in our project, we implemented four machine learning models. First of all, the first nearest neighbor or KNN. This model compares new data with existing data and find the closest match. Second one is support vector matching or SVM. This model separates users by creating boundaries between different classes. The third one is a random forest. This model uses multiple decision tree and combines their result to improve accuracy. Fourth one is a neural network. This model learns pattern automatically and helps improve user identification.
Here we show the results we get from the machine learning implementation using the touch analytics dataset. We can see that the neural network achieved the highest accuracy of 79.05%, which used around 200 epochs for the training. Then from the classical machine learning models, we can see the random forest model achieved 78.10% accuracy. The false acceptance rate was 0.53% and the false rejection rate was 22.30%. Overall, the neural network showed the best performance for user identification, at least for this touch analytics dataset.
Here we show the result using the chemical dataset. On the right side, the accuracy graph shows that the decision tree achieved a best accuracy of 65.92%. SVM performed moderately while KNN and neural networks show lower accuracy. On the left side, the feature important graph shows which features contributed most to the model performance. And this helps us understand which sub features are more important for user identification. And this result shows that the chemical dataset is more complex and decision tree perform best for this dataset.
Yeah, to make our system more reliable, we also use explainable AI or XAI. Accuracy alone is not enough. We also need to understand how the model makes decision and identify possible bias. We use tools like SHAP and random forest feature. Important to understand which features are most important. We also follow responsible AI principles such as fairness, transparency, accountability, trustworthiness, and privacy. In practice, we focused on reporting performance, checking bias, explaining decisions, and ensuring ethical deployment. This helps build trust and makes the system more reliable and secure.
Conclusion, touch dynamics proved to be an effective method for user authentication. Machine learning helped improve biometric accuracy and overall system performance. This system also enhances the smartphone security by identifying user based on their touch behavior. From our result, we can see that neural network achieved the best accuracy for touch analytics dataset, while decision to perform best for the chimerical dataset. Overall, our system provides a reliable and secure user identification approach. Thank you everyone for your patience in viewing our presentation.